Hello everyone, I am Reshma Ravindran. Welcome to Mathedify. Today we will be discussing about polygons. So before getting into polygons, let's discuss some basic ideas. First of all, open figures and closed figures. So let's see one by one. Open figures. So what do you mean by open figures? Open figures are geometric shapes that do not enclose any area. If I draw the alphabetical letter C, this letter itself is an open figure and this doesn't enclose any area. So this is open figure. Now this is an open figure. This is an open figure and this is an open figure. It consists of curves or line segments but that do not meet or connect to form a closed loop. See, in these four examples, we are not able to identify any loop, right? Any closed loop. So these are open figures. Now, closed figures. Closed figure is a geometric shape that encloses an area. Like if I write the letter D, see, there's a closed loop over here, right? And this is enclosing this much area. And if I draw something like this, see, this is enclosing this much area and this is a closed loop. This is connected using, formed using line segments or curves, right? So these are closed figures. If I simply draw a circle, this is a closed figure. Now, see, this is a closed figure. We are not able to identify which is the starting point and which is the ending point. But in case of open figures, we can recognize two different points. And one may be the starting point and other may be the ending point. So this is the difference between open figures and closed figures. Now let's get into polygon. Okay. So this is not a polygon, but this is a polygon. This is not a polygon. This is a polygon. So can you just let me know what is a polygon by identifying the difference? This is an open figure, right? And this is a closed figure. So polygons cannot be open figure. So polygons must be closed figure. This is our first property of polygon. Now, this is not a polygon, but this is a polygon. Now, see, though this circle is a closed figure, this is not a polygon. But here, this rectangle comes under the polygon category. So, what is the difference between these two figures? First one is closed, the other one is also closed. But the first one is formed of curved line and the second one is formed of straight line segments, right? So the figure should be formed of straight line segments. So we got the second property as well. What is it? Straight line segments. Okay, so polygons are closed and polygons should be formed of straight line segments. So let's rephrase it and form a good definition. A polygon is a closed geometric figure that is formed by connecting straight line segments. See, these are the two important points. It should be closed and it should be formed of straight line segments. So a polygon is a closed figure made up of line segments. Now, polygon is derived from two Greek words. Poly, which means many, and gonia, which means angle. Now you can see some examples here. This is a closed figure made up of straight lines. So obviously polygon. This one is also polygon and this is also polygon. Now you understood what is polygon, right? Now let's see what are the key characteristics of polygons. Closed figure. We already discussed it. Straight sides. Yes, it is formed of line segments. Now comes vertices. So, what are vertices? The singular form is vertex. If there are more than one vertex, then we will call it as vertices. This is plural form. The sides where two line segments or sides meet. Sorry, the point where the two sides meet is known as vertex. This is a vertex. Here, this is also a vertex. This one is vertex. This is another vertex. This is another vertex. See, this is a closed figure made up of straight lines. So that means this is a polygon and these line segments are known as sides. So how many sides are here? 5 sides are present in this polygon. Now, vertices. How many vertices are here? 5 sides are here, right? So, 5 vertices will be here. 1, 2, 3, 4, 5. Yes, 5 vertices. Now comes interior angles. So, these are interior angles, right? 1, 2, 3, 4, 5. So, number of sides is 5, number of vertices is 5. Now, interior angles, number of interior angles is also 5. So, if a polygon is having 10 sides, how many vertices will it have? 10 vertices. How many interior angles will it have? 10 interior angles. Okay. So, if a polygon is having n sides, it will be having n interior angles as well as n vertices. That's the relationship between vertices, sides, and interior angles. Now, let's get into naming of polygons. Let's name the polygons. When the number of sides is 3, what will be the name of polygon? Actually, this is the minimal polygon. Why? You have any idea why this polygon having 3 sides is minimal? Because if I take one line segment, I won't be able to draw a polygon. If I take one more line segment, then also I won't be able to form a closed figure, right? Polygons are closed figures. But if I take one more line segment, I will be able to form a closed figure made of line segments. So that means in order for a figure to become a polygon, that it should have minimum it should have 3 sides. Okay. So this is known as minimal polygon, and this is the polygon having 3 sides is triangle. You all know triangle, right? This is a triangle. Now comes four-sided polygons. Four-sided polygons. Do you know any examples? Square, rectangle, trapezium, kite, rhombus, parallelogram. These are all closed figures having 4 sides, right? So these all come under the category quadrilateral. Quadrilateral. Okay. Quad means 4 and lateral means sides. So four-sided figures are known as quadrilaterals. So polygons having 4 sides are known as quadrilaterals, and some of the examples are square, rectangle, trapezium, parallelogram, rhombus, kite, etc. Now comes 5-sided polygon. It is known as pentagon. Pentagon. Now 6-sided polygon. It is known as hexagon. Hexagon. Now comes 7-sided polygon. It is known as heptagon or septagon. Heptagon or septagon. Now 8-sided polygons are known as octagon. In chemistry, we used to hear octet electronic configuration and all, right? Oct means 8. So polygons having 8 sides are known as octagon. Now 9. nonagon. Now comes 10 and it is decagon. These are the popular names, and polygons with more than 10 sides generally use the gun suffix. I will know what is that. If a polygon is having 12 sides, then we will usually call it as 12 gun. If it is having 35 sides, then we will call it as 35 gun. So we will use this gun as suffix. So these are the popular polygons: triangle, quadrilateral, pentagon, hexagon, heptagon or septagon, octagon, nonagon, and decagon. Now let's get into the classification of polygons. Convex and concave. First one is concave convex polygons. If the line segment connecting any 2 points within the polygon remains inside the polygon, then it is a convex polygon. So let's discuss this using an example. What is this? This is a closed figure made up of straight lines. That means this is a polygon having how many sides? 1, 2, 3, 4, 5 sides. So this is pentagon, right? Okay. Now, see, if I connect any 2 points using a line segment, all these lie inside this pentagon. So this is known as a convex pentagon. Okay. So that means if we connect any 2 points using a line segment and that line segment lies within the polygon, then that polygon will be known as convex polygon. Since we took pentagon here, this is convex pentagon. Now let's get into the features. Every interior angle is less than 180 degrees. See, this will not be greater than 180. This is not greater than 180. This one. See, all these are less than 180 degrees. So every angle should be less than 180 degree. In which type of polygon? Convex polygon. All diagonals lie inside the polygon. What do you mean by diagonal? If the line segments connecting two alternate vertices. In case of rectangle, see, if I connect these two vertices, alternate vertices using this line segment, this is known as diagonal. The line segment connecting the adjacent vertices are known as sides. Okay, so the main difference between sides and diagonals are sides are line segment connecting adjacent vertices, and diagonals are line segments connecting um, alternate vertices. Okay, that means non-adjacent vertices. Now let's get into the concave polygon. If the line segment connecting any 2 points may pass outside the polygon boundary, then it is concave polygon. Let's take the example of pentagon, but let's restructure it in a different manner. See, what polygon is this? 1, 2, 3, 4, 5-sided closed polygon, which is pentagon, right? Now, this is, see, this is one vertex and this is another vertex. If I connect these two vertices, then that line segment is lying outside the polygon. See, this is interior of the polygon. This is interior of the polygon and this particular line segment is lying outside the polygon, right? So this particular polygon is known as concave polygon. Since this polygon is having 5 sides, we can call it as concave pentagon. Did you understand the difference? In convex polygons, the line segments connecting vertices cannot lie outside the polygon. They are lying inside the polygon. But here, some line segments may pass the boundary. See here, in this particular example, this line segment passed the boundary, right? It is lying outside the polygonal boundary. So this is concave polygon. Now let's get into the features. At least one interior angle is greater than 180 degree. Let's see. Any angle is greater than 180. This won't be greater than 180. This is also less than 180, less than 180, less than 180. Here we can see a reflex angle here, right? This is straight angle, 180 degree. So this one will be greater than 180 degree. So yes, in this figure also one angle is greater than 180 degree. At least one interior angle is greater than 180 degree. Now, at least one diagonal may lie outside the polygon. These are not adjacent vertices, right? And the line connecting them is known as diagonal. And that diagonal is lying outside the polygon. So this is concave polygon. So what are the key features? Line segment connecting two points lie within the polygon in case of convex polygon. In that every interior angle is less than 180 and all diagonals should lie inside the polygon. But in case of concave polygon, line segment connecting points may pass the polygonal boundary and at least one interior angle will be greater than 180 degree. At least one diagonal may lie outside the polygonal boundary. These are the main differences between convex polygon and concave polygon. Now, this is a very important point. A polygon is either convex or concave. There is no polygon that is both convex and concave. If you identify something as a polygon, then it must be concave. Otherwise, it will be convex. But a polygon, the same polygon cannot be convex and concave at the same time. Okay. Now, the next classification. First classification was concave polygon versus convex polygons, right? Now, next classification is a regular and irregular polygon. A regular polygon is a polygon that has all sides of equal length and all angles of equal measure. If a polygon is having equal sides and also equal angles, then we call them as regular polygons. The polygons which are not regular are known as irregular polygons. Okay, so let's see the examples here. So here I have drawn an equilateral triangle. Equilateral triangle means what? Triangle having equal sides. And what is the specialty of that triangle? Each angle is 60 degree. That means it is having equal angles as well. So this is a regular polygon. Why? Equilateral triangle is having all the sides as equilateral triangle is having equal measured sides, right? And this is a right triangle. Right triangle. And in right triangle, hypotenuse is always greater than base and altitude. So this one will be greater. And this angle will be 90 degree and these are not 90 degrees. So angles are different, sides are different. So this is not regular polygon. Hence it is irregular polygon. Okay. So polygons which are having equal sides and equal angles are known as regular polygon. In another way, we can call it as polygons which are equilateral as well as equiangular. Polygons which are equilateral and equiangular are known as regular polygons. Polygons which are not regular are known as irregular polygons. Now, here we discussed about triangles, right? If a quadrilateral is regular, what will be it? What we call that quadrilateral? Square, right? Why? Square is having same sides and same angles. Each angle is 90 degree in square. So, same sided for polygon and equiangular polygon. So, the quadrilateral which is regular is called square. And what about rectangle? Rectangle is having, yeah, every angle is 90 degree, but opposite sides are equal. Not all sides are equal. So it can't be a regular polygon. It is a irregular polygon. Now comes the next one. Polygons having five sides. Let's erase this. Okay. Polygons having five sides. What is it called? Pentagon, right? If a pentagon is having same sides and same angles, then we can call it as regular pentagon. If a hexagon is irregular, we call it as regular hexagon. If a decagon is regular, we can call it as regular decagon. Okay, so a polygon means what? All its sides are equal and all its angles are equal. Now let's get into this. Sum of interior angles. Now we are going to discuss about sum of interior angles of polygons. So here there is a table, and using this table we can arrive at some conclusion. Triangle. Okay, so first one is triangle. Number of sides. Yes, we know. Three sides. Number of triangles. Okay, let's see. Here a triangle is present. Can we draw any diagonal over here? No, right? So here only one triangle is present. So we can write it over here. Number of triangles is 1. Sorry, number of triangles is 1, and sum of interior angles. We have already learned about angle sum property of triangle, right? What is it? Angle sum property of triangle. Sum of all interior angles of a triangle is 180 degree. Okay, so 180 degree. Now comes quadrilateral. Okay, let's see. How many sides? Four sides. How many triangles will be there? Here, to find out the number of triangles, we are drawing diagonals, maximum number of diagonals from the same vertex. Okay, so I'm choosing this as the vertex. So this one will be diagonal. So how many triangles are here? One, two. So let's write it over there. Two triangles. See, two triangles. So what will be the sum of interior angles? This one's sum will be of 180 degree, and this triangle's sum will be of 180 degrees. So since a quadrilateral is having two triangles, their sum of interior angles will be 2 into 180 degree, right? 360 degree. Now comes pentagon. How many sides? Five sides. Now let's see the figure. Let's consider this vertex. I am drawing a diagonal like this. Now, considering the same vertex, we will be getting another diagonal. Now, how many triangles are here? One, two, three. So, so what will be the sum of interior angles? 180 degree, 180 degree, 180 degree. Sum of interior angles of each triangle is 180 degree. So, that means since pentagon is having three triangles inside it, the sum of interior angles will be 3 into 180 degree. Now comes hexagon. What is the number of sides? 6. Okay. I am considering this as the vertex. So, sorry, it is a curved line. Let's erase it. Okay, then now I will try to draw a straight line. Yeah, better than before, right? So, this is a diagonal, and now comes, oh, this is also again. You understood, right? These are diagonals. Now comes this one. One, two, oh, sorry. Yeah, it's better. Three, four. Now we drew three diagonals and we got four triangles. So 6. Now 4 triangles. So sum will be 4 into 180 degree. So if a polygon has 5 triangles, then its sum of interior angles will be 5 into 180 degree. If a polygon has 10 interior angles, then what will happen? Sorry, 10 triangles, then its sum will be 10 into 180 degree, right? So let's see. So now the task is to find out the number of triangles in every polygon. See, can you connect this number of sides and number of triangles, number of sides, number of triangles. Here, 3 sides and 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. So, any relationship? 3 minus 2 is 1. Here, this 4 minus 2 is 2. 5 minus 2 is this 3. 6 minus 2 is this 4. So, that means number of sides minus 2 will give you number of triangles. Right? Okay. So, let's see about heptagon. Heptagon will be having 7 sides. So, what will be the number of triangles? Without drawing any figure, will you be able to find out? Yes, 7 minus 2, which is equal to 5 triangles. Since heptagon is having 5 triangles, sum of interior angles will be 5 into 180 degree. Yes. So it goes on like this for every polygon. Now, if a polygon is having n number of sides, okay, n gun, right? So n number of sides, what will be the number of triangles present in it? Yes, n minus 2. So what will be the sum of interior angles? N minus 2 into 180 degree. N minus 2 times 180 degree. If a polygon is having n sides, then what will be the sum of interior angles? N minus 2 times 180 degree. What is this n? Number of sides of any polygon. If a polygon is having 4 sides, then what will be the sum of interior angles? 4 minus 2 times 180 degree. If a polygon is having 100 sides, what will be the sum of interior angles? 100 minus 2 times 180 degree. Okay. Now let's see some questions. Find the sum of interior angles in a pentagon. Okay. So first of all, we have to write the given data. Pentagon. So what will be the number of sides a pentagon have? 5, right? So we can use small letter n to to indicate the number of sides. N is equal to 5. Now we need to find out sum of interior angles. So let's write sum of interior angles is equal to, what's the formula? N minus 2 times 180 degree. Now here n is 5. So substitution step. 5 minus 2 times 180 degree, which is equal to 5 minus 2 is 3. 3 times 180 degree, 540 degree. So sum of interior angles of a pentagon is 540 degree. Now next question. If the sum of interior angles in a hexagon is 720 degree, what is the measure of each interior angle? So in the question it is given that hexagon, but they are having that hexagon is having same interior angles. Otherwise, this each interior angle, this will not be there in the question. Okay, so we can consider or we can conclude this as regular hexagon. Now, sum is given 720 degree. Now, what is the measure of each interior angle? The sum of all angles. How many angles does the hexagon have? 6 angles. So sum of all those 6 angles will be 720 degree. And we have to find out each angle. How will you do that? Okay, let's write the given data. Sum of interior angles is equal to 720 degree. Now we know n, right? Number of sides. Yes, it is 6. Now we have to find out each interior angle. Each interior angle can be found out using the formula sum of interior angles divided by number of sides or number of angles. If hexagon is having 6 sides, what does it mean? Hexagon is having 6 angles, right? So sum of interior angles by number of sides will be 720 by 6, which will be equal to 120 degree. So we got another formula, right? What is it? If sum is given, sum of interior angles is given and number of sides is known, then we will be able to find out each interior angle. Each interior angle is equal to sum of interior angles divided by number of sides or number of interior angles. Now, if the interior angle of a regular polygon is 150 degree, how many sides does the polygon have? So we don't know anything, right? Here we know only one thing. What is it? Sum of interior angles. So sum is equal to 150 degree and we don't know n, right? And we have to find out the value of n. Okay, let's write the formula. N minus here. Oh, sorry. I made a mistake here. Here sum is not 150 degree. What is 150 degree here? Each interior angle is 180 degree. Now, let's write the formula of sum of interior angles n minus 2 into 180 degree. Sum divided by each number of sides will give you each interior angle. Okay, see, sum divided by interior angle will give you each interior angle will give you number of sides or sum divided by number of sides will give you each interior angle. Okay. Now n minus 2 into 180 degree is equal to 150 degree. Now n minus 2 into 180 degree is equal to 150 degree times this n will come over here. So 150 degree n. Okay. Now let's do this. N times 180 degree will be 180 n minus 2 times 180 will be 360, which is equal to the RHS 150 n. Now 180 n minus 150 n will give you 360. Now what's the difference? 30 n is equal to 3n is equal to 3. Oh, 150. 30 n is equal to, I just got blanked out. 360. N is equal to 360 by 30, which is equal to 12. So number of sides is equal to 12. Polygon has interior angles measuring 160 degree each. Is it possible for this polygon to be regular? Let's see. If interior angle is 160 degree, then what will be the number of sides? Let's assume that a polygon is having interior angle 160 degree. So n minus 2 times 180 degree by this 160 degree will give you n, which is equal to n minus 2 180 is equal to 160 n. 180 n minus 360 is equal to 160 n. 180 n minus 160 n is equal to 360. Now 20 n is equal to 360. N is equal to 360 by 20, which is equal to 80. Now, here 18 is a whole number, right? So, there exists a polygon with 160-degree each. Sometimes in these sort of questions, we may get 18.2, 18.5 like that. So, number of sides can't be decimal, right? If we get n as 18.5, then there doesn't exist a polygon with 160 as angle. But here n is equal to 18, which is a whole number. So that means there exists a polygon, there exists a polygon with interior angle 160-degree. Okay. Now let's move to the next topic, exterior angles. Here you can see a triangle with exterior angles, right? Okay, let's give some angles. 60-degree, 50-degree, now 70-degree. How will you find out exterior angles at every vertex? Let's name the triangle A, B, C. So at vertex A, exterior angle at vertex A, what will be the exterior angle at vertex A? Can you find out any relation between interior angle and exterior angle at the same vertex at A? They form a linear pair, right? 180-degree. So 50-degree plus this exterior angle will give you 180-degree. So exterior angle at A equal to 180-degree minus 50-degree, which is equal to 130-degree. So this will be 130-degree. So what about here? Interior angle is 60-degree. So what will be exterior angle? 180-degree minus 60-degree, which will be equal to 120-degree. Now at the vertex C, interior angle is 70-degree. So what will be the exterior angle? 180-degree minus 70-degree, which will be equal to 110-degree. Okay. So relationship between interior angle and exterior angle at the same vertices, they form a linear pair. At each vertex of the polygon, interior angle and exterior angle will form a linear pair. What do you mean by linear pair? They are supplementary angles. Their sum will be 180-degree. Okay, let's see this. If the exterior angle of a polygon is 60-degree, what is the measure of each interior angle? Very simple, right? 180-degree minus 60-degree will give you the interior angle, which is equal to 120-degree. Now, let's see the sum of interior angles. Okay, so this is a pentagon. Let's extend the sides. Okay, now let's extend here and like this. So we have extended everything. Now let's give, mm, let this be 120-degree. This one will be 110. This one will be 110. Let it be like this. Okay. 100-degree, 100-degree. Okay. So I have given some measures to every interior angle. Now find out the sum of exterior angles. In order to find out the sum of exterior angles, you should be able to find out every exterior angle, right? Okay. Let's find out every exterior angle. What will be this angle? 180-degree minus 120-degree. So 60-degree. What about this one? This one 180 minus 110, which is equal to 70. What about this one? This will be 80. And what about this one? This one will be also 80. So this one 110 is already here. So 70. Now let's add all the interior angles. 60-degree plus 70-degree plus 80-degree plus 80-degree plus this 70-degree. 1, 2, 3, 4, 5. Okay. So what is the sum? Yes, we will get 360-degree. Now let's see the polygon we discussed earlier. This one. Here the exterior angles were 130, 110 and 120. Here also we will get 360 degree as the sum of exterior angles. So this is a polygon and this one was a pentagon, right? So no matter what the polygon is, the sum of exterior angles will always remain as 360 degree. Sum of exterior angles of a polygon is 360 degree. So what about exterior sum of exterior angles of a pentagon? It will be 360 degree. What about a tengon? That means a decagon, 360 degree. 34 gun, the sum of exterior angles will be 360 degree. So if a polygon um, is having any number of sides or anything, no matter what the number of sides or what the polygon is, its sum will or sum of exterior angles will always be 360 degree. Find the measure of each exterior angle in a regular hexagon. Okay, here we need to find out each exterior angle. And in earlier, we needed to find out each interior angle. At that time, we divided sum of interior angles by number of sides and we got each interior angle. So in order to find out each exterior angle, what we can do? We can just divide sum of exterior angles by number of sides, which is equal to n. So we will be getting each exterior angle. In this case, what is n? Regular hexagon. So n will be 6. And what will be the sum of exterior angles? 360 degree. So divided by 6. What will be the answer? 6 1 is 6. 660 is 360. So 60 degree. Each exterior angle in a regular hexagon is 60 degree. Let's see another question. If the measure of each exterior angle in a regular polygon is 72 degree, how many sides does the polygon have? Here, sum divided by n is equal to each exterior angle. Likewise, sum of exterior angles by each exterior angle will give you number of sides. So in this case, sum will be 306 degree and each exterior angle will be 72 degree as per the question. So this will be equal to what? Number of sides. So let's find out what will be the answer here. 72 into 1 is 72, 72 5s are 360. So n is equal to 5. Now, next question. In a regular pentagon, what is the ratio of the measure of an exterior angle to an interior angle? We need to find out the ratio of exterior angle to interior angle. So, for that, we need to know what is the measure of exterior angle and interior angle here. So, exterior angle. This is regular pentagon. So exterior angle will be sum of exterior angles will be 360 degree. That divided by number of sides, that will be 5, will give you what? The 72 degree, each exterior angle. And here, interior angle. How will you find out interior angle? Sum divided by number of sides. Sum of interior angles of a regular pentagon will be 540 degree by 5. So what will be the answer? 108 degree. Now, ratio of exterior angle to, ratio can be denoted using is to, right? Exterior angle to is to interior angle equal to 72 is to 108, which can be written as 72 by 108, which is equal to, here we will get, yes, 2 by 3, and which can be written as 2 is to 3. See, this is how we find out the ratio. Moving on to the next question. A convex quadrilateral has interior angles in the ratio 2 is to 3 is to 4 is to 6. Find the measure of each angle. So only ratio is given. So let's determine the angles. Let the angles be 2x, 3x, 4x, and 6x. And the sum is 360 degree. 2x plus 3x plus 4x plus 6x will give you 15x. 15x equal to 360 degree, x equal to 360 by 15, which is equal to 24. Now we found out the value of 24. Okay, let's find out each angle. 2x, that means 2 into 24. That will be 48 degree. Now 3x. 3 into 24. What will be the answer? 4 3s are 12 or 72 degree. Now 4x. 4 into 24. What will be the answer? 16 1, 2 4s are 8, 96 degree. 5x, that, sorry, 6x. 6 into 24, that is equal to 4, 6 4s are 24. 144 degree. See, find the measure of each angle. We found out 48 degree, 72 degree, 96 degree, and 144 degree. So these are the basic ideas that come under this chapter, polygons. So please subscribe the channel for more such video sessions. Thank you.